Okay students, good morning. Today we'll do some question from class 10, illustrated Opt.Mathematics. Topic is trigonometric ratios of multiple angles. Exercise 5.1a, page 217. We do question number 8 to 14. Let's start from question number 8. Now question number 8 we have to prove. Now 80. Solution here to prove sin cube A minus cos cube A, sin cube A minus cos cube A all upon sin A minus cos A is equal to 1 plus 1 by 2 sin 2A. Now here this is equal to sin cube A minus cos cube A all upon sin A minus cos A. This numerator in the form of A cube minus B cube. So using formula sin A minus cos A sin square A minus sin A cos A plus sin A cos A plus cos A square A all upon sin A minus cos A. We use the formula of A cube minus B cube equal to A minus B, A square plus AB plus B square by using this formula. This equal to this sin A minus cos A cancel out, remaining sin square A plus sin A cos A plus cos A square A. Now we know that sin square A plus cos square A it makes 1. So sin square A plus cos square A writing together. Then sin A cos A, that is 1 by 2 times 2 sin A cos A. This sin A cos A multiplying by 2 by 2. Now sin square A plus cos square A, its value is 1 plus 1 by 2. This 2 sin A cos A, that is formula of sin 2A. So this is the RHS proved. Now students, next question 8b. On 8b we have to prove sin alpha minus square root of 1 plus sin 2 alpha all upon cos alpha minus square root of 1 plus sin 2 alpha is equal to cot alpha. Now LHS is equal to sin alpha minus square root of 1 plus sin 2 alpha all upon cos alpha minus square root of 1 plus sin 2 alpha. Now this equals to sin alpha minus this 1. For 1 we can put sin square alpha plus cos square alpha plus sin 2 alpha, that is 2 sin alpha cos alpha whole upon cos alpha minus square root of, again for this one we can write sin square alpha plus cos square alpha plus sin 2 alpha, that is 2 sin alpha cos alpha. We know that sin square theta plus cos square theta equal to 1. Now this equal to sin alpha minus square root of cos square alpha sin square alpha plus 2 sin alpha cos alpha. It makes A square plus B square plus 2AB. A plus B whole square. Hope so here. Sin alpha plus cos alpha whole square all upon cos alpha minus square root of sin alpha plus cos alpha whole square, because a square plus b square plus 2ab equal to a plus b whole square. Now this equal to sin alpha minus square and square root cancel out each other, so remaining sin alpha plus cos alpha all upon cos alpha minus again same square and square root cancel, remaining sin alpha plus cos alpha. Now this equal to sin alpha minus cos alpha all upon cos alpha minus sin alpha minus cos alpha. On numerator sin alpha cancel out, remaining minus cos alpha. On denominator cos alpha cancel out, remaining minus sin alpha. Minus cancel out, remaining cos alpha upon sin alpha, that is cot alpha, which is RHS. So proved. Now next question, 8C. On 8C, you have to prove solution here. To prove 1 plus 10a whole upon 1 minus 10a its whole square equal to 1 plus sin 2a whole upon 1 minus sin 2a. Now RHS equal to 1 plus sin 2a whole upon 1 minus sin 2a. For 1 we can put sin square a plus cos square a plus sin 2a, that is to sin a cos a whole upon 1 sin square a plus cos square a minus sin 2a to sin a cos a. This equal to, you can write cos square a plus 2 sin a cos a plus sin square a. This equal to cos a plus sin a whole square whole upon cos a minus sin a whole square. This equal to cos a plus sin a whole upon cos a minus sin a its whole square. This equal to both numerator and denominator both dividing by cos a. Cos a upon cos a plus sin a upon cos a all upon cos a upon cos a minus sin a upon cos a its whole square. Both the numerator and the denominator dividing by cos a. Now this equal to cos a by cos a 1 plus sin by cos 10, 1 plus 10a all upon 1 minus sin a by cos a again tan its whole square equal to LHS. Now next question. Question number 8D. On 8D, have to prove cos square a minus sin square a, cos square a minus sin square a equal to sin 4a upon 2 sin 2a, sin 4a upon 2 sin 2a. Now RHS equal to sin 4a upon 2 sin 2a. Sin 4a, that is sin 2 times of 2a upon 2 sin 2a. Sin 2 times of 2a, that is sin 2 theta 1. So you can use formula 2 sin 2a dot cos 2a all upon 2 sin 2a, because sin 2 theta equal to 2 sin theta dot cos theta. Now 2 sin a cancel out, remaining cos 2a. Its formula is cos square a minus sin square a equal to LHS. Now we go to next question, 80. On 80 we have to prove cos to the power 4 alpha minus sin to the power 4 alpha equal to cos 2 alpha. Now we are just equal to cos to the power 4 alpha minus sin to the power 4 alpha. Now this equal to cos to the power 4 alpha, that is cos square alpha whole square, minus sin to the power 4 alpha, that is sin square alpha whole square. This is in the form of a square minus b square. So we can use formula cos square alpha plus sin square alpha and cos square alpha minus sin square alpha, because we know that a square minus b square equal to a plus b, a minus b by this one. Now the value of cos square alpha plus sin square alpha, that is 1, and cos square alpha minus sin square alpha, this is formula of cos 2 alpha. Cos 2 alpha into 1 cos 2 alpha, that is RHS proof. Now we go to next question, 8F. On 8F we have to prove cos to the power 6a, cos to the power 6a minus sin to the power 6a equal to cos 2a times 1 minus 1 by 4 sin square 2a. Now LHS equal to cos to the power 6a minus sin to the power 6a is equal to cos square a whole cube minus sin square a whole cube, making a cube minus b cube form. Now using for the a cube minus b cube, cos square a minus sin square a minus b. Now cos square a whole square, a square plus cos square a dot sin square a square plus ab plus sin square a whole square. So for now a cube minus b cube equal to a minus b a square plus ab plus b square by using this formula. Now we know that cos square minus sin square, this formula is cos 2a. Cos 2a, then this first and last cos square a whole square plus sin square a whole square, a square plus b square whole, cos square a whole square plus sin square a whole square, putting together. Now remaining plus cos square a dot sin square a. This equal to cos 2a. This is a square plus b square using formula a plus b whole square minus 2ab. So cos square a plus sin square a whole square minus 2 cos square a dot sin square a plus cos square a dot sin square a, because a square plus b square equal to a plus b whole square minus 2ab by using this formula over here, cos square a whole square plus sin square a whole square. Now this equal to cos 2a cos square a plus sin square a, each value is 1, so 1 whole square minus 2 cos square sin square a plus cos square sin square a, remaining minus sin square a cos square sin square a, that is sin square cos square same. Now this equal to cos 2a 1 square is 1 minus this multiplying this term by 4 by 4, so 1 by 4 times 4 sin square a cos square a, multiplying this term by 4 by 4. Now this equal to cos 2a 1 minus 1 by 4 sin square a cos square, that is 2 sin a cos a whole square, 2 sin a cos a whole square. Now this equal to cos 2a 1 minus 1 by 4 2 sin a cos a, that is formula of sin 2a, so sin 2a whole square. This equal to cos 2a, then 1 minus 1 by 4 sin 2a whole square, that is sin square 2a, sin square 2a, which is the RHS group. Now we go to the equation 8g. On 8g we have to prove cos to the power 8a plus sin to the power 8a, this equal to 1 minus sin square 2a plus 1 by 8 sin to the power 4 2a. Now RHS equal to cos to the power 8a plus sin to the power 8a. This equal to cos to the power 4a whole square plus sin sine to the power 4a whole square. A square plus b square form. This equals to cos to the power 4a minus sine to the power 4a whole square plus 2 cos to the power 4a dot sine to the power 4a. We use the formula of a square plus b square. Is a square plus b square equals to a minus b whole square plus 2ab by using this formula. A square plus b square equal to a minus b whole square plus 2ab. So cos to the power 4a minus sine to the power 4a whole square plus 2 cos to the power 4a dot sine to the power 4a. Now this equals to cos to the power 4a again cos square a whole square minus sine to the power 4a, that is sine square a whole square, making a square minus b square form within bracket. Now it's whole square plus this one 2 cos to the power 4a is sine to the power 4a multiplying by 8 by 8. So we can write 1 by 8 and 8 times 2 cos to the power 4a dot sine to the power 4a. Multiply this term by 8 by 8 divided 8. Now this equals to within bracket a square minus b square form. So this formula is a plus b, a minus b. So you can write cos square a plus sine square a and cos square a minus sine square a, its whole square plus 1 by 8, 8 to the 16 dot 16 sine to the power 4a dot cos to the power 4a. Now value of cos square a plus sine square a, its value is 1. So 1 dot cos square a minus sine square a, its formula is cos 2a its whole square plus 1 by 8 16 sine to the power 4a cos to the power 4a, that is 2 sine a dot cos a its whole to the power 4. Sine a cos a whole power 4. Now this equal to cos 2a 1 the cos 2a whole square is cos square 2a. You can write cos 2a whole square in this step, cos 2a whole square plus 1 by 8 to sine a cos a, that is sine 2a its whole power 4. This equal to cos 2a whole square is cos square 2a plus 1 by 8 sine to the power 4 2a. Sine 2a whole power 4 is sine to the power 4 2a. Now cos square 2a is 1 minus sine square 2a plus 1 by 8 sine to the power 4 2a. This equal to RHS group. Now we go to next question. 8 yes. On 8 yes, we have to prove cos to the power 4 12 theta. Cos to the power 4 12 theta minus sine to the power 4 12 theta. This equals to cos 24 theta. Cos 24 theta. Now L is equal to cos to the power 4 12 theta minus sine to the power 4 12 theta. Now making a square minus b square form, we can write cos square 12 theta whole square minus sine square 12 theta whole square. Now a square minus b square, a plus b, a minus b, using formula cos square 12 theta plus sin square 12 theta and cos square 12 theta minus sin square 12 theta, because a square minus b square equal to a plus b, a minus b, by using this formula. Now cos square 12 theta plus sin square 12 theta, its value is 1. Cos square a plus sin square a form. And this cos square 12 theta minus sin square 12 theta, cos square a minus sin square a form. So its formula is cos 2a, 2 times of 12 theta, because cos square a minus sin square equal to cos 2a by using this formula. Now this equal to 1 into cos 12 into 2, 24. So cos 24 theta, that is the RHS. So cos 24 theta. Okay students, now we go to next question. 8I. Now 8I, we have to prove cos 2a plus cos 2b, cos 2a plus cos 2b whole square plus sin 2a minus sin 2b whole square. This equal to 4 cos square a plus b. Now here is just equal to cos 2a plus cos 2b whole square plus sin 2b minus sin 2b whole square. Now expanding both by using for the a plus b whole square and a minus b whole square. So this equal to cos square 2a plus 2 cos 2a dot cos 2b plus cos square 2b. Similarly, a minus b whole square. Sin square 2a minus 2 sin 2a dot sin 2b plus sin square 2b, because a plus b whole square equal to a square plus 2ab plus b square, and a minus b whole square equal to a square minus 2ab plus b square, by adding these two formula. Now cos square a, cos square 2a, sin square 2a, writing together. Sin square 2a plus cos square 2a. Then cos square 2b, sin square 2b. So sin square 2b plus cos square 2b. Now remaining terms, 2 cos a, 2 cos 2a, cos 2b plus 2 cos 2a, cos 2b minus 2 sin 2a, sin 2b. Now sin square 2a plus cos square 2a, its value is 1, plus sin square 2b, cos square 2b, its value also 1, plus from last two terms taking 2 common, remaining cos 2a dot cos 2b minus sin 2a dot sin 2b. This equal to 1 plus 1, 2 plus 2 cos 2a cos 2b minus sin 2a sin 2b. Cos a cos b minus sin a sin b form. So which formula is cos a plus b. So cos 2a plus 2b. Now this equal to, we use the formula again, equal cos a cos b minus sin a sin b equal to cos a plus by using this formula. Now from this you can take 2 common, remaining 1 plus cos 2 times of a plus b. 2a plus 2b, taking 2 common, so 2 times of a plus b. Now this equal to 1 plus this cos 2 theta from cos 2 theta, that is cos 2 theta equal to 2 cos square theta minus 1, so 2 cos square a plus b minus 1, because cos 2 theta equal to 2 cos square theta minus 1 by using this one. Now 1 cancel out, remaining 2 into 2 cos square a plus b. Now 2 to the 4 equal to 4 cos square a plus b. This is RHS. So proof. Now we go to next question. 8. Next we have to prove cos cube alpha dot cos 3 alpha plus sin cube alpha dot sin 3 alpha. This equal to cos cube 2 alpha. Now we know that cos 3a equal to 4 cos cube a minus 3 cos a. From this you can get formula of cos cube a. Cos cube a equal to 1 by 4 times cos a plus cos 3, and sin 3 equal to 3 sin a minus 4 sin cube a. From this you can get formula of sin cube a. Sin cube a equal to 1 by 4 times 3 sin a minus sin 3a. So by using this formula, cos cube a plus cos cube a and sin cube a we can use over here, or sin cube alpha and cos cube alpha. Now taking LHS, cos cube alpha dot cos 3 alpha plus sin cube alpha dot sin 3 alpha. Cos cube alpha, that is 1 by 4 times 3 cos alpha plus cos 3 alpha by using this formula. Cos cube a equal to 1 by 4 times 3 cos a plus cos 3 alpha dot cos 3 alpha is same plus sin cube alpha, that equal to 1 by 4 times 3 sin alpha minus sin 3 alpha dot sin 3 alpha is same. Now this equal to 1 by 4 common from these two terms, 1 by 4 common. Now 3 cos alpha into cos 3 alpha, 3 cos alpha cos 3 alpha, cos 3 alpha into cos 3 alpha, cos square 3 alpha plus 3 sin alpha into sin 3 alpha, 3 sin alpha into sin 3 alpha minus sin 3 alpha into sin 3 alpha minus sin square 3 alpha this equal to 1 by 4. Then cos square theta alpha minus sin square theta alpha. Cos square theta alpha minus sin square theta alpha. From first and third, here 3 common, plus 3 common, cos theta alpha, cos alpha, cos theta alpha dot cos alpha minus plus sin theta alpha dot sin alpha. Now this cos square a minus sin square alpha, this is cos 2a, formula cos 2a. So 1 by 4 here, cos 2 into 3 alpha. Plus 3 cos a cos b plus sin sin, that is cos a minus b. So cos 3 alpha minus alpha. Because cos square a minus sin square equal to cos 2a, and cos a cos b plus sin a sin b equal to cos a minus b, by adding these two formula. Now this equal to 1 by 4 times cos 3 coming out, 2 inside, 3 outside, cos 3 times out 2 alpha. 2 times of 3 alpha equal to 3 times of 2 alpha. 3 to the 6, 2 to the 6. Plus 3 cos 3 alpha minus 2 alpha is 3 alpha minus alpha is 2 alpha. Cos 3 cos 2 alpha. Now this equal to 1 by 4 times 3 cos 2 alpha. 3 cos 2 alpha plus cos 3 times 2 alpha. Cos 3 times of 2 alpha. This is in the form of cos cube a formula. 1 by 4, 3 cos a plus cos 3. Here, instead of a is 2 alpha. 3 times of cos 2 alpha, cos 3 times of 2 alpha. That is cos cube 2 alpha equal to RHS proof. This is in the same pattern in terms of 2 alpha. 1 by 4, 3 cos 2 alpha plus cos 3 times of 2 alpha. Now we go to next question. Question number 9. Number 9, again we have to prove. On 9a, solution here to prove. Two 10 pi divided upon 4 minus a. 2 10 pi divided upon 4 minus a whole upon 1 plus 10 square pi divided upon 4 minus a. This equal to cos 2a. Now LHS equal to 210 pi divided by 4 minus a whole upon 1 plus 10 square pi divided upon 4 minus a. This is in the form of 210 theta upon 1 plus 10 square theta. This is the formula of sin 2 theta. So sin 2 pi divided by 4 minus a, because sin 2 theta equal to 210 theta upon 1 plus 10 square theta. Formula of sin 2 theta in terms of 10 theta by using this formula. So this equal to sin 2 into pi divided by 4, that is pi divided by 2 minus 2 into a, 2a minus 2a. This equal to Sine pi by 2, that is 90 degree. Pi is equal to 180, so pi by 2 90. Sine 90 degree minus 2a. Sine 90 minus theta from is equal to cos theta. Equal to cos 2a, because sine 90 degree minus theta equal to cos theta. That is RHS. So proved. Now 9b. On 9b, we have to prove 1 minus 10 square, 1 minus 10 square, pi divided by 4 minus alpha, all open 1 plus 10 square, pi divided by 4 minus alpha. This equal to sine to alpha. Now here is equal to 1 minus 10 square, pi divided by 4 minus alpha, all upon 1 plus 10 square, pi divided by 4 minus alpha. This is in the form of 1 minus 10 square theta, all upon 1 plus 10 theta. This is the formula of cos 2 theta. So cos 2 times of pi divided by 4 minus alpha, because cos 2 theta equal to 1 minus 10 square theta all upon 1 plus 10 square theta by using this formula. Now this equal to cos 2 times of pi by 4, that is pi by 2, pi divided by 2 minus 2 into alpha to alpha. We know that pi divided by 2 is 90 degree, so cos 90 degree minus 2 alpha is equal to sin 2 alpha, because cos 90 minus theta equal to sin theta. This is equal to RHS. Proof. Now we go to next question, 9c. On 9c we have to prove 1 minus 2 sin square 45 degree minus 3. 1 minus 2 sin square 45 degree minus 3a equal to sin 6a. Now that is equal to 1 minus 2 sin square 45 degree minus 3a. This is 1 minus 2 sin square theta. This is the formula of cos 2 theta. So cos 2 times of 45 degree minus 3a, because cos 2 theta equal to 1 minus 2 sin square theta by using this formula. So this equal to cos 2 times of 45 degree 90 degree minus 3 to the 6, so minus 6a. Cos 90 minus theta, so this equal to sin theta, so sin 6a, because cos 90 degree minus theta equal to sin theta. This is RHS. So proved. Now next question, 9d. On 9d we have to prove 10 pi divided upon 4 plus a, 10 pi divided upon 4 plus a equal to sec 2a plus 10 2a, sec 2a plus 10 2a. Now here is equal to 10 pi divided upon 4 plus a. Pi divided by 4, that is 45 degrees. So tan 45 degree plus a. This equal to tan a plus b becomes so tan 45 degree plus tan a upon 1 minus tan 45 degree dot tan a. Tan a plus b equal to, because tan a plus b equal to tan a plus tan b, tan a plus tan b all upon 1 minus tan a tan b by using this formula of tan a plus b. Now tan 45 its value is 1, so 1 plus tan a all upon 1 minus tan a, because tan 45 degree equal to 1, putting its value. Now this equal to 10. There is 1 plus tan a sin a by cos a all upon 1 minus tan a sin a by cos a. This equal to cos a plus sin a, cos a plus sin a all upon cos a, all upon cos a minus sin a all upon cos a. This denominator cos a cancel, remaining cos a plus sin a, cos a plus sin a all upon cos a minus sin a. Now using its conjugate, cos a minus sin a, its conjugate is cos a plus sin a all upon cos a plus sin a, using conjugate of the denominator. Cos a plus sin a, cos a plus sin a, that is cos a plus sin a all square all upon cos square a minus sin square a plus b minus b, cos square a minus sin square a, cos a plus sin a, that is cos square a plus sin square a square plus b square plus 2 sin a into cos a all upon cos square a minus sin square is cos 2a. Now cos square a plus sin square a, its value is 1. 1 plus 2 sin a cos a is sin 2a all upon cos 2a. 1 by cos 2a plus 1 by cos 2a plus sin 2a upon cos 2a. 1 by cos 2a, that is sec 2a, sin 2a upon cos 2a is tan 2a, that is RHS proof. Now we go to next question, question number 9e. Solution yet. To prove, 9e we have to prove sin 45 degree plus a, sin 45 degree plus a dot sin 45 degree minus a, sin 45 degree minus a, is equal to 1 by 2 times cos 2a, 1 by 2 times cos 2a. Now LHS equal to sin 45 degree plus a dot sin 45 degree minus a. This equal to this sin a plus b from this sin a minus b. So using formula, sin a plus b, sin a cos b. So sin 45 cos a plus cos a sin b, cos 45 sin a, sin 45 minus a, sin a minus b becomes so Sin 45 dot cos A minus cos 45 dot sin A, because sin A plus B equal to sin A cos B plus cos A sin B, and sin A minus B equal to sin A cos B minus cos A sin B by using these two formula. Now this equal to A plus B, A minus B. So A square minus B square. So sin square 45 degree dot cos square A minus cos square 45 degree dot sin square A, because A plus B, A minus B equal to A square minus B square. Now sin square 45, the value of sin 45 is 1 by root 2, so 1 by root 2 whole square dot cos square A minus cos square 45, that is 1 by root 2 whole square dot sin square A. 1 by root 2 whole square is 1 by 2 cos square A minus 1 by 2 sin square A. 1 by 2 common, now remaining cos square A minus sin square A. Cos square A minus sin square A, that is formula of cos 2A. So 1 by 2 cos 2A, that is RHS proof. Now next question 9F. From 9F we have to prove tan pi divided by 4 plus theta. Tan pi divided by 4 plus theta plus tan divided by 4 minus theta. This is equal to 2 sec 2 theta. 2 sec 2 theta. Now we are just equal to tan pi divided by 4 plus theta plus tan pi divided by 4 minus theta. Pi divided is 180, so pi divided by 4 is 45. 180 by 4, 45. So tan 45 degree plus theta plus tan 45 degree minus theta. Tan A plus B from tan A minus 1. Now using formula, tan 45 degree plus tan theta all upon 1 minus tan 45 degree dot tan theta plus tan A minus B from, so tan 45 degree minus tan theta all upon 1 plus tan 45 degree dot tan theta, because tan A plus B equal to tan A plus tan B all upon 1 minus tan A into tan B, and tan A minus B equal to tan A minus tan B all upon 1 plus tan A into tan B by adding these two formulas. Now this equal to, we know that tan 45 its value is 1, so 1 plus tan theta all upon 1 minus tan theta plus 1 minus tan theta all upon 1 plus tan theta, because tan 45 degree equal to 1. Now taking LCM, 1 plus tan theta and 1 minus tan theta. LCM divided by denominator of first term. 1 minus tan theta cancel, remaining 1 plus tan. Multiply with numerator 1 plus tan. 1 plus tan into 1 plus tan, 1 plus tan theta whole square. Plus second part, LCM divided by denominator 1 plus 10 cancel, remaining 1 minus 10 into 1 minus 10, 1 minus 10 theta whole square. Now this is a plus b whole square form, this is a minus b using formula 1 square plus 2 into 1 into 10 theta plus 10 theta whole square plus 1 minus 10 theta whole square, that is 1 square minus 2 into 1 into 10 theta plus 10 theta whole square whole upon a minus b plus b, a square minus b square, so 1 square minus 10 theta whole square. So 1 plus 2 10 theta plus 10 square theta plus 1 minus 2 10 theta plus 10 square theta whole upon 1 minus 10 square theta. 1 plus 1 2 10 theta to 10 theta cancel out this 10 square plus 10 square to 10 square, 2 plus 2 10 square theta whole upon 1 minus 10 square theta. Now this equal to 2 common, 1 plus 10 square theta whole upon 1 minus 10 square theta. This equal to 2 upon 1 minus 10 square theta upon 1 plus 10 square. 1 minus 10 square theta upon 1 plus 10 theta, that is 1 half cos 2 theta. So 2 upon cos 2 theta, 2 into 1 by cos 2 theta, 1 by cos, that is sec, so 2 sec 2 theta equal to RHS. So proof. Now we go to next question. Question number 9 G. On 9G we have to prove 2 sin 45 degree minus theta, 2 sin 45 degree minus theta dot sin 135 degree minus theta equal to cos 2 theta. Now LHS equal to 2 sin 45 degree minus theta dot sin 135 degree minus theta. Now this is in the form of 2 sin A sin B. 2 sin A sin B. You can use this formula. Also separate it, sin A minus B, sin A minus B. So 2 sin 45 minus theta, that is sin A sin 45 cos theta minus cos 45 sin theta, sin A minus B, sin A cos B minus cos theta. This sin 135 minus theta, that is sin 135 cos theta minus cos 135 degree dot sin theta, because sin A minus B equal to sin A cos B minus cos A sin B by using this formula. Now this equals to the value of sin 45 is 1 by root 2 and sin 135 is also 1 by root 2. So putting the 1 by root 2 cos theta minus 1 by root 2 sin theta. Again 1 by root 2 cos theta minus 1 by root 2 sin theta, because sin 45 degree equal to sin 135 degree equal to 1 by root 2. Both have the same value, 1 by root. Now these two, this and this same, so taking 1 by root 2 common over here, 1 by root 2 common, cos theta minus sin theta, 1 by root 2 common, cos theta minus sin theta. Here cos 135 and cos 135 degree equal minus 1 by root 2. Cos 135 is minus 1 by root 2. So minus minus it makes plus. Its value is minus 1 by, here minus 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 plus. So it becomes a plus b, a minus b becomes, so 2 times 1 by root 2 cos theta whole square minus 1 by root 2 sin theta whole square. A minus b, a plus b, a square minus b square, because a minus b, a plus b equal to a square minus b square. Now this equal to 1 by root 2 whole square is 1 by root 2 cos theta whole square is cos square theta, 1 by 2 cos square theta minus 1 by 2 sin square theta. 1 by 2 common to come out, remaining cos square theta minus sin square theta. It will cancel, so cos square theta minus sin square theta under this, cos square theta minus sin square. This is 1 half cos 2 theta equal to RHS proved. Now we go to the next question. 9 yes. On 9 yes, we have to prove tan alpha plus pi divided by 3, alpha plus pi divided by 3 dot tan alpha minus pi divided by 3 equal to 1 plus 2 cos 2 alpha, 1 plus 2 cos 2 alpha whole upon 1 minus 2 cos 2 alpha. Now LHS equal to tan alpha plus pi divided by 3 dot tan alpha minus pi divided by 3. We know pi divided is 180 degrees, so pi divided by 3 is pi divided equal to 180 degrees. So pi divided by 3 is 60 degrees. So tan alpha plus 60 degree dot tan alpha minus 60 degree. Now using formula tan a plus b, tan a minus b, tan a plus b, tan alpha plus tan 60 whole upon 1 minus tan alpha dot tan 60 degree dot tan alpha minus 60, that is tan alpha minus tan 60 whole upon 1 plus tan alpha into tan 60 degree, because tan a plus b equal to tan a plus tan b whole upon 1 minus tan a into tan b, and tan a minus b equal to 10a minus 10b all upon 1 plus 10a into 10b by using these two formula. Now we know tan 60 degree, that is its value is root 3, so tan alpha plus root 3 upon 1 minus root 3 tan alpha dot tan alpha minus root 3 upon 1 plus root 3 tan alpha, because tan 60 degree equal to root 3. Now is equal to 10a plus 10b, a plus b, a minus b, a square minus b square, so tan alpha whole square minus root 3 whole square upon this 1 square minus root 3 tan alpha whole square, because a plus b into a minus b equal to a square minus b square. This equal to tan square alpha minus 3 all upon 1 minus 3 tan square alpha. Now RHS is in terms of cost, so changing into cost. This equal to tan square, that is sin square alpha upon cos square alpha minus 3 all upon 1 minus 3 sin square alpha upon cos square alpha. This equal to sin square alpha minus 3 cos square alpha all upon cos square alpha. Then denominator cos square alpha minus 3 sin square alpha all upon cos square alpha. This denominator cancel out, cos square alpha cancel out, remaining this equal to sin square alpha minus 3 cos square alpha all upon cos square alpha minus 3 sin square alpha. Now we can write this sin square alpha plus cos square alpha minus 4 cos square alpha, 4 cos square alpha upon cos square alpha plus sin square alpha minus 4 sin square alpha. Now this equal to sin square alpha plus cos square alpha 1 minus 4 cos square alpha all upon 1 minus 4 sin square alpha. You are taking minus common, you can write minus 3 cos square alpha minus sin square alpha, taking minus common, 3 sin square alpha minus cos square alpha. Then this equal to minus minus cancel, 3 cos square alpha minus sin square alpha whole upon 3 sin square alpha minus cos square alpha. Now this equal to, we need cos 2 alpha, so 3 cos square alpha, that is 2 cos square alpha minus 2 sin square alpha plus sin square alpha plus cos square alpha, rearranging terms, whole upon 3 sin square alpha, that is 2 sin square alpha plus cos square alpha minus 2 cos square alpha plus 2 sin square alpha. Here 2 common, cos square alpha minus sin square alpha. Sin square alpha plus cos square alpha is 1. All upon is 1 minus 2 common, cos square alpha minus sin square alpha. This equal to 2 cos square alpha minus sin square alpha, cos 2 alpha plus 1 all upon 1 minus 2 cos square minus sin square, that is cos 2 alpha. So this equal to 1 plus 2 cos 2 alpha all upon 1 minus 2 cos 2 alpha equal to RHS root. Okay student, now we go to next question 9i. On 9i we have to prove sin theta dot sin 60 degree minus theta, sin theta dot sin 60 degree minus theta dot sin 60 plus theta, sin 60 degree plus theta, this equal to 1 by 4 sin 3 theta, 1 by 4 sin 3 theta. Now LHS equal to sin theta dot sin 60 degree minus theta dot sin 60 degree plus theta. Now this equal to sin theta sin 60 minus theta, using formula sin 60 dot cos theta minus cos 60 dot sin theta. Similarly sin 60 plus theta, that is sin 60 dot cos theta plus cos 60 dot sin theta. We use two formula over here. Sin A minus B equal to sin A cos B minus cos A sin B, and sin A plus B equal to sin A cos B plus cos A sin B by the two formula. Now we know that sin 60 its value is root 3 by 2, so sin theta root 3 by 2 cos theta minus cos 60 equal to 1 by 2. 1 by 2 sin theta dot sin 60 root 3 by 2 cos theta plus cos 60 1 by 2 sin theta equals sin 60 equal to root 3 by 2 and cos 60 equal to 1 by 2. Now this equal to sin theta a minus b equals to a square minus b square, so root 3 by 2 cos theta whole square minus 1 by 2 sin theta whole square. This equal to sin theta into root 3 by 2 whole square is 3 by 4, so 3 by 4 cos square theta minus 1 by 4 sin square theta. So 1 by 4 common, 1 by 4 sin theta remaining 3 cos square theta minus sin square theta. This equal to 1 by 4 sin theta. We know that cos square theta equal to 1 minus sin square theta. So 3 times 1 minus sin square theta minus sin square theta. This equal to 1 by 4 sin theta. 3 into 3 sin square theta. 3 minus 3 sin square theta minus sin square theta. This equal to 1 by 4 sin theta 3 minus 4 sin square theta. Now 1 by 4 sin theta into 3 sin theta minus sin theta into 4 sin theta, that is 4 sin theta. 1 by 4 3 sin theta minus 4 sin theta. This is power of sin 3 theta. So sin 3 theta, that is RHS. Now we go to next question, 9J. On 9J, we have to prove tan A plus tan 60 degree plus A, tan A plus tan 60 degree plus A plus tan 120 degree plus A, tan 120 degree plus A. This equal to 3 times tan 3, 3 tan 3. Now we are just equal to tan A plus tan 60 degree plus A plus tan 120 degree plus A. Now by using formula of tan A plus B, we can expand these two terms, second and third. First term tan A same, tan 60 plus A, that is tan 60 plus tan A whole upon 1 minus tan 60 dot tan A plus tan 120 plus A, that is tan 120 degree plus tan A whole upon 1 minus tan 120 degree dot tan A, because tan A plus B equal to tan A plus tan B whole upon 1 minus tan A into tan B by using this formula. Now putting the value 10, 60 root 3, 10, 120 minus root 3. So 10a plus root 3 plus 10a whole upon 1 minus root 3 10a plus 10, 120 minus root 3 plus 10a whole upon 1 minus root 3 10a because 10, 60 root 3 and 10, 120 is minus root 3. Now this equal to 10a plus root 3 whole upon 1 minus root 3 10a plus 10a minus root 3 whole upon 1 plus root 3 10a. Now taking LCM of all three terms together, 1 minus root 3 10a into 1 plus root 3 10a. This 10a multiplied with both terms, so 10a into a plus b minus a square minus b square. So 1 square minus root 3 10a whole square plus second part 10a plus root 3 into 10a plus root 3 with 1 plus root 3 10a 1 plus root 3 10a plus third 10a plus minus root 3 10a minus root 3 into 1 minus root 3 10a 1 minus root 3 10a. Now this equals to 10a into 1 square, that is 10a 10a into root 3 10a whole square. 3 10a whole square is 3 10 square. 10 into 3 10 square is 3 10 cube a minus 3 10 cube a plus 10 into 1 10a 10 into root 3 10a plus root 3 10 square a root 3 into 1 plus root 3 into root 3 10a 3 10a again 10a into 1 10a 10a into root 3 10a minus root 3 10 square a. So minus root 3 into 1 minus root 3 minus plus root 3 into root 3 10a 3 10a whole upon a minus b a plus b a square, that is 1 square minus b square, that is root 3 10a whole square. Now this equal to 3 10 cube a 10a 10a to 10a plus 3 10a plus 10a 3 plus 3 6 plus 1 7 8 plus 1 9 9 10a minus 3 10 cube a. This root 3 10 square a root 3 10 square a positive cancel out plus root 3 minus root 3 cancel out 9 10a minus 3 10 cube a whole upon 1 minus root 3 10a whole square, that is 3 10 square a. On numerator taking 3 common, remaining 3 10a minus 10 cube a 3 10a minus 10 cube a whole upon 1 minus 3 10 square a. 3 10a minus 10 cube a whole upon 1 minus 3 10 square, that is 1 of 10 3. So 3 times of 10 3 equal to I'll just prove. Now we go to next question. Now question number 10A. To prove square root of 2 plus square root of 2 plus square root of 2 plus 2 cos 8a, 2 cos 8a, this equal to 2 cos a. Now LHS equal to square root of 2 plus square root of 2 plus square root of 2 plus 2 cos 8a. This equal to square root of 2 plus square root of 2 plus square root of, you are taking 2 common, remaining 1 plus cos 8a. This equal to square root of 2 plus square root of 2 plus square root of 2, 1 plus cos 8a. We know that 1 plus cos 2 theta equal to 2 cos square theta. 1 plus cos 2 theta equal to cos theta. This 8a, that is 2 times of y. So we can write by this one 2 cos square y. 2 cos square y is equal to square root of 2 plus square root of 2 plus square root of 2 to the 4, 4 cos square 4a. So 4 cos square 4 cos square 4a is equal to square root of 2 plus square root of 2 plus 4 cos square 4a is square root is 2 cos 4a. 2 cos 4a is equal to square root of 2 plus square root of, again 2 common over here, remaining 1 plus cos 4a. Again using same formula, we can write square root of 2 plus square root of 2 dot 1 plus cos 4a, that is 4a is 2 times of 2a. So we can write 2 cos square 2a, 2 cos square 2a. 1 plus cos 4a equal to 2 cos square 2a. Now this equal to square root of 2 plus 2 to the 4, 4 cos square 2a, square root of 4 cos square 2a is equal to 2 plus 4 cos square 2a is square root is 2 cos is 2a plus 2 cos 2a is equal to, again square root of 2 common, 1 plus cos 2a, 1 plus cos 2a, 1 plus cos 2a, that is 2 cos square a, square root of 2 into 2 cos square a, square root of 4 cos square a. Square root of 4 cos square a is 2 cos a, 2 cos a equal to RHS. Okay, in this question, this formula is repeated multiple times. So 1 plus cos 2 theta equal to cos square theta. 1 plus cos 8a, 2 cos square 4a. Again 1 plus cos 4a, 2 cos square 2a. Finally 1 plus cos 2a, 2 cos square a. The pattern is same, 1 plus cos 2 pattern. Now we go to 10b. be, we have to prove 1 upon sine 10 degree, 1 upon sine 10 degree minus root 3 upon cos 10 degree equal to 4. Now LHS equal to 1 upon sine 10 minus root 3 by cos 10 degree. Now taking LCM, sine 10 into cos 10, sine 10 degree into cos 10. Then LCM divided numerator, cos 10 1 the cos 10 degree minus root 3 sine 10 degree. Now this equal to multiplying both numerator divided by 2. So we can write 2 cos 10 degree minus root 3 sine 10 degree all upon 2 sine 10 degree dot cos 10 degree, because multiplying by 2 by 2. Now this equal to 2 into 2, again multiplying by 2 by 2 on the numerator. Then we can write 1 by 2 cos 10 degree minus root 3 by 2 sine 10 degree upon 2 sine 10 cos 10, 2 sine A cos A. So sine 2 is 2 into 10 degree, because multiplying by 2 by 2 on the numerator and 2 sine A cos A equal to sine 2A, 2 sine A cos A equal to sine 2A. Now to do the whole, 1 by 2 that was sine 30, sine 30 degree dot cos 10 minus root 3 by 2 value of cos 30, cos 30 dot sine 10 degree all upon sine 2 into 10, that is sine 20 degree equal to 4 sine 30 cos 10 sine A cos B minus cos 30 sine 10 cos A sine B, sine A minus B comes, so sine 30 degree minus 10 degree all upon sine 20 degree, because sine A cos B minus cos A sine B equal to sine A minus B by using this formula. Now this equal to sine 30 minus 10, that is sine 20, 4 sine 20 upon sine 20, sine 20 sine 20 cancel, remaining 4, that is RHS. So proved. Now we go to next question, question number 10C. On 10C we have to prove root 3 cosec 40 degree, root 3 cosec 40 degree minus equal to 4 minus sec 40 degree, 4 minus sec 40 degree, that is root 3 cosec 40 degree plus sec 40 degree equal to 4. Now taking LHS, root 3 cosec 40 plus sec 40 degree. Cosec that equal to 1 by sine. So root 3 by sine 40 plus sec that is 1 by cos. So 1 by cos 40 degree. Taking LCM sine 40 degree dot cos 40 degree. Then upper part root 3 cos 40 degree plus sine 40 degree. Multiplying both numerator denominator by 2. You can write 2 times of root 3 cos 40 plus sine 40 all upon 2 sine 40 dot cos 40. Multiplying by 2 by 2. Now this equal to 2 again multiplying by 2 by 2 on numerator. 2 into 2 then root 3 by 2 cos 40 degree dot plus 1 by 2 sine 40 degree whole upon 2 sine 40 cos 40 that is sine 2 into 40 degree because multiplying by 2 by 2 on the numerator. And 2 sin a cos a equal to sin 3. Then this equal to 2 to the 4 root 3 by 2 that is 60. So sin 60 dot cos 40 plus 1 by 2 that is cos 60 dot sin 40 all upon sin 2 into 40 sin 80 degree. Now this equal to 4 sin 60 cos 40 plus cos 60 sin 40 sin a cos b plus cos a sin b. So sin 60 degree plus 40 degree all upon sin 80 degree because sin a cos b plus cos a sin b equal to sin a plus b by adding this formula. Now sin 60 plus 40 100 sin 100 degree upon sin 80 degree equal to 4 sin 100 that sin 180 minus 80 degree 100 equal to 180 minus 80 upon sin 80 sin 180 minus theta also sin 180 minus theta sin theta. So 4 sin 80 degree upon sin 80 because sin 180 minus theta equal to sin theta. Now sin 80 cancel equal to 4 equal to RHS proved. Now we go to next question. Now question number 10D. On 10D we have to prove root 3 cosec 20 degree minus sec 20 degree equal to 4. Now we have just equal to root 3 cosec 20 minus sec 20. Cosec 20 that is 1 by sin 20. So root 3 upon sin 20 minus sec 20 that is 1 by cos sec into 1 by cos 20. Taking LCM sin 20 dot cos 20 Root 3 into cos 20. Root 3 cos 20 minus sin 20. Now what the numerator denoted by 2 2. We can write 2 times root 3 cos 20 minus sin 20 upon 2 sin 20 dot cos 20 multiplying by 2 by 2 by 2 by 2. Now this equal to 2 into 2 again multiply numerator by 2 by 2. 2 into 2 then root 3 by 2 cos 20 minus 1 by 2 sin 20 whole upon sin 2 sin theta cos theta. So sin 2 into 20 multiplying by 2 by 2 on the numerator and to sin a cos a equal to sin 2a. Now this equal to 2 to the 4 root 3 by 2 that is 60 sin 60 dot cos 20 minus 1 by 2 that is cos 60 dot sin 20 sin 2 into 20 sin 40 degree who sin a cos b minus cos a sin b. So sin 60 minus 20 minus 60 degree minus 20 degree all upon sin 40. 60 minus 20 that is 40. So 4 sin 40 degree upon sin 40 degree. This equal to sin 40 cancel 4 equal to RHS. So root. Now we go to next question. Question number 11A. We have to prove cos square alpha plus sin square alpha dot cos 2 beta is equal to cos square beta plus sin square beta dot cos 2 alpha. Now delta is equal to cos square alpha plus sin square alpha dot cos 2 beta equal to cos square alpha plus sin square alpha cos 2 beta, that is 1 minus 2 sin square beta. This equal to cos square alpha plus sin square alpha into 1 sin square alpha plus minus minus 2 sin square alpha sin square beta. Cos square alpha plus sin square alpha equal is 1 minus 2 sin square alpha dot sin square beta and RHS equal to cos square beta plus sin square beta dot cos 2 alpha equal to cos square beta plus sin square beta. Cos 2 alpha, its formula is 1 minus 2 sin square alpha. 1 minus 2 sin square alpha is equal to cos square beta plus sin square beta into 1 sin square beta plus minus minus 2 sin square alpha dot sin square beta. Cos square beta plus sin square beta equal is 1 minus 2 sin square alpha dot sin square beta. Therefore, LHS equal to RHS root 2. Now we go to next question. Example B. On example B, we have to prove cosine A dot cos A. Cosine A dot cos A minus cos A dot sin A equal to sin A. Now LHS equal to cosine A dot cos A minus cos A dot sin A is equal to, taking common, cosine A cos A common, cosine A cos A common, remaining cos square A minus sin square A equal to cosine A cos A, that is 2 times of cosine A cos A dot cos square A minus sin square, that is cos 2A. Cos square A minus sin square is cos 2A. Now to sin A cos A, that is sin 2A dot cos 2A. To sin 2A dot cos 2A, that is sin 2 times of 2A equal to sin 4A equal to RHS root. Now we got next question. 11C. On 11C, here to prove cos A dot cos 2A, cos A dot cos 2A dot cos 4A dot cos 8A equal to sin 16A upon 16 sin A. Now RHS equal to sin 16A upon 16 sin A. Sin 16A equal to sin 2 times of 18 upon 16 sin A. Now formula using formula of sin 2 theta to sin theta cos theta. So 2 sin 8A dot cos 8A, because sin 2 theta equal to 2 sin theta dot cos theta all upon 16 sin 8. This equal to sin 8A, again 2 cos 8A, cos sin 8A we can write sin 2 times of 4A all upon 16 sin A. Again 2 cos 8A dot sin 2 times of 4A, that is 2 sin 4A dot cos 4A all upon 16 sin A. Now 2 to the 4 option, 2 to the 4 cos 8A cos 4A, then sin 4A, sin 4A, that is sin 2 times of 2A all upon 16 sin A. Now this equal to 4 cos 8A cos 4A, 4 cos 8a cos 4a dot sin 2 times 2a, that is 2 sin 2a, 2 sin 2a dot cos 2a whole upon 16 sin a. Now this equal to 4 to the 8, coefficient 4 to the 8 cos 8a cos 4a cos 2a. This sin 2a, that is 2 sin a cos a. Sin 2a is 2 sin a cos a. This whole upon 16 sin a. Now this equal to coefficient 8 to the 16, 16, then cos a cos 8a dot cos 4a dot cos 2a dot cos a, then sin a whole upon 16 sin a. 16 cancel out, sin a cancel out, remaining cos a dot cos 2a dot cos 4a dot cos 8a, that is LHS. Now we go to next question, 11D. On 11D, we have to prove sec 8a minus 1 whole upon sec 4a minus 1. This is equal to tan 8a upon tan 2a. Now LHS equal to sec 8a minus 1 whole upon sec 4a minus 1. Changing sec in terms of cos, sec equal to 1 upon cos, so sec 8a 1 by cos 8a minus 1, sec 4a 1 upon cos 4a minus 1. Taking LCM on both numerator and denominator, we get 1 minus cos 8a upon cos 8a whole upon 1 minus cos 4a upon cos 4a. Now this equal to 1 minus cos 8a upon cos 8a into cos 4a upon 1 minus cos 4a, reversing the fraction. Now this equal to 1 minus cos 8a, this equal to 2 sin square 4a upon cos 8a dot cos 4a upon 1 minus cos 4a, that is 2 sin square 2a, because 1 minus cos 2 theta equal to 2 sin square theta by using this formula. So 1 minus cos 8a, that is 2 sin square 4a, half of 8a is 4a, and 1 minus cos 4a, 2 sin square 2a, half of 4a is 2a. Now this equal to 2 sin 4a, sin square 4a, here sin 4a, so 2 sin 4a cos 4a, remaining another sin 4a, so sin 4a, breaking sin square 4a in terms of sin 4a, whole upon cos 8a dot 2 sin square 2a, that is 2 sin square 2a, that is same. Now 2 sin 4a cos 4a, that is sin 8a. Sin 2 times of 4a, sin 8a upon cos 8a. Dot is sin 4a, that is 2 sin 2a dot cos 2a upon 2 sin square 2a. Sin 4a cos upon cos 4a, that is 10 sin 80 upon cos 80, that is 10 80 dot 2 to cancel, sin 2a sin 2a cancel, remaining cos 2a upon sin 2a, that is 1080 cos 2a upon sin 2a, that is cot 2a, cos pi sin cot 2a, that is 1080 cot, that is 1 upon 10, so 10 2a, cot 2a equal to 1 upon 10 2a. This equal to 1080 1 the 1080 upon 10 2a, that is RHS. So proof. Now we go to next question. 11E. On 11E, we have to prove 2 cos A plus 1 into 2 cos A minus 1 into 2 cos B minus 1 into 2 cos 4A minus 1. This is equal to 2 cos 8A plus 1. Now LHS equal to 2 cos A plus 1, 2 cos A minus 1, 2 cos 2A minus 1 into 2 cos 4A minus 1. Now this equal to the first and second. It makes A plus B, A minus B. So 2 cos 2A whole square minus 1 whole square. A plus B minus A square minus B square. Remaining same. 2 cos 2A minus 1, 2 cos 4A minus 1. Because A plus B, A minus B equal to A square minus B square. Now 2 cos 2A, 2 cos A here, 2 cos A whole square, that is 4 cos square minus 1 square is 1. Then 2 cos 2A minus 1, 2 cos 4A minus 1. Now this equal to 2 cos square, 4 cos square, that is 2 times of 2 cos square minus 1. Then 2 cos 2A minus 1, 2 cos 4A minus 1. 2 cos square A, its formula is 1 plus cos 2A. 2 times 1 plus cos 2A minus 1. Then 2 cos 2A minus 1, 2 cos 4A minus 1. Because 2 cos square theta equal to 1 plus cos 2 theta by this formula. Now opening this 2 under 2 plus 2 cos 2A minus 1. Then 2 cos 2A minus 1 2 cos 4a minus 1. Now 2 minus 1 1, so 2 cos 2a plus 1, 2 minus 1 1, and 2 cos 2a minus 1, and 2 cos 4a minus 1. Again a plus b, a minus b form. So 2 cos 2a, 2 cos 2a whole square minus 1 square. 2 cos 2a whole square is 4 cos square 2a minus 1 square is 1. Then 2 cos 4a minus 1. 2 into 2 cos square 2a. 4 cos square 2a equal to 2 into 2 cos square 2a minus 1. Then 2 cos 4a minus 1. 2 cos square 2a, again using the same formula, 1 plus cos 4a. So 2 times 1 plus cos 4a. 2 cos square 2a equal to 1 plus cos 4a minus 1. And 2 cos 4a minus 1 is equal to 2 into 2 cos 4a minus 1. 2 into 2 under 2 plus 2 cos 4a minus 1. Then 2 cos 4a minus 1 is equal to 2 cos 4a 2 minus 1 plus 1. 2 cos 4a plus 1. 2 cos 4a minus 1. Again a plus b, a minus b form. A square minus b square. So 2 cos 4a whole square, that is 4 cos square 4a minus 1 square is 1. This is equal to 2 into 2 cos square 4a minus 1. Now this is equal to 2 cos square 4a, that is 1 plus cos 8a minus 1 equal to 2 plus 2 cos 8a minus 1. This is equal to 2 cos 8a plus 1 equal to RHS. In this question, this formula is repeated. 2 cos square theta equal to 1 plus cos 2 theta. Repeated mode. Now we go to next question. Now question number 12a. So here to express sin 3a in terms of sin a. Sin 3a in terms of sin a. Now sin 3a equal to sin 2a plus a. Breaking 3a in terms of 2a plus a. Now it becomes sin a plus b form. So using formula of sin a plus b, we can write sin 2a cos a plus cos 2a sin a, because sin a plus b equal to sin a into cos b plus cos a into sin b by this formula. Now sin 2a, that is 2 sin a into cos a, is the formula of sin 2a, dot cos A is same plus cos 2A, that is 1 minus 2 sin square dot sin. In terms of sine, so using formula of cos 2A in terms of sine pattern. Now this is equal to 2 sin A cos A into cos A square plus 1 into sin A minus 2 sin square into sin A minus 2 sin cube A is equal to 2 sin A cos square A, that is 1 minus sin square A plus sin A minus 2 sin cube A is equal to 2 sin A into 1, 2 sin A into minus sin square A minus 2 sin cube A plus sin A minus 2 sin cube A. Now in like terms, 2 sin A plus sin A, 3 sin A minus 2 sin cube A minus 2 sin cube A minus 4 sin cube A. So sin 3 equal to this sin A minus 4 sin cube A. This is the required expression of sin 3 in terms of sin A. Now we go to next question. Question number 12D. On 12B, solution here to express cot 3A in terms of tan A. Cot 3A in terms of tan A. Now cot 3 equal to 1 upon tan 3 equal to 1 upon tan 3, that is tan 2A plus A. Now 1 upon tan A plus B form, so using formula tan 2A plus tan A whole upon 1 minus tan 2A dot tan A. Now reversing it, 1 minus tan 2A dot tan A whole upon tan 2A plus tan A, because tan A plus B equal to tan A plus tan B whole upon 1 minus tan A into tan B by using this formula. Now tan 2A, using formula tan 2A, then write 1 minus 2 tan A upon 1 minus tan square dot tan A whole upon tan 2A, again 2 tan A upon 1 minus tan square A plus tan A. Now this equal to, taking LCM, 1 minus tan square A, 1 minus tan square A, LCM on numerator, then 1 minus tan square A, 1 minus tan square A, minus 2 tan A into tan A, minus 2 tan square A, minus 2 tan square A, whole upon on the denominator LCM is also 1 minus tan square A. On the numerator, 2 tan A plus tan A into 1 minus tan square A, tan A 1 tan A minus tan cube A plus tan A minus tan cube A. This equal to denominator this cancel out, 1 minus tan square remaining 1 minus 3 tan square 1 minus 3 tan square all upon 2 tan plus tan 3 tan minus 10 kb. So cot 3a equal to 1 minus 3 tan square all upon 3 tan minus 10 kb. This is the required form of cot 3a in terms of tan a. Now we go to next question. Now question number 13. Question number 13. A. Solution here. To prove cos 80 degree equal to 1 by 4 times square root of 10 plus 2 root 5. Without using table or calculator. Without using calculator or table. Right solution. Let us suppose theta equal to 18 degree. Then 5 theta equal to 90 degree. 90 degree. 18 5 90. Or 3 theta plus 2 theta equal to 90 degree. Breaking 5 theta in terms of 3 theta plus 2 theta. Or 2 theta equal to 90 degree minus 3 theta. Taking sign on both sides. Taking sign on both sides. We get sin 2 theta equal to sin 90 degree minus 3 theta. Or sin 2 theta, that is 2 sin theta cos theta equal to sin 90 degree minus theta. Sin 90 minus from the is equal to cos 3 theta. Or 2 sin theta dot cos theta equal to cos 3 theta, that is 4 cos cube theta minus 3 cos theta. Or 2 sin theta dot cos theta equal to, taking cos theta common, remaining 4 cos square theta minus 3 cos theta. And so now we need the value of sin theta. Remaining 2 sin theta equal to 4 cos square theta minus 3. Or 2 sin theta equal to 4 cos square theta, that is 1 minus sin square theta minus 3. Or 2 sin theta equal to 4 minus 4 sin square theta minus 3. or 2 sin theta equal to 4 minus 3 1 minus 4 sin square theta, or 4 sin square theta plus 2 sin theta minus 1 equal to 0, which is quadratic in terms of sin theta, which is quadratic in terms of sin theta, where A equal to 4, B equal to 2, and C equal to minus 1. So using formula, sin theta equal to minus B plus minus square root of B square minus 4AC all upon 2A equal to minus B minus 2 plus minus square root of B square minus 4A 4C minus 1 all upon 2 into A 2 into 4 equal to minus 2 plus minus square root of B square 2 square 4 minus 5 plus 16 all upon 8 equal to minus 2 plus minus square root of 20 all upon 8 equal to minus 2 plus minus square root of root 20, that is 5 to the 20, so 2 root 5 all upon 8. 2 common, remaining minus 1 plus minus root 5 all upon 8. Now minimizing this, 2 for the x, so this equal to minus 1 plus minus root 5 all upon 4 equal to plus minus root 5 minus 1 all upon 4. Since theta is 80 degree, lies in first quadrant, since theta equal to 80 degree, which lies in first quadrant, so value of sin 80 degree must be positive. Therefore, sin 80 degree equal to root 5 minus 1 all upon 4. After this, then cos 80 degree equal to square root of 1 minus sin square 80 degree, because cos theta equal to square root of 1 minus sin square theta by this formula. Now this equal to square root of 1 minus sin square 80 degree, so root 5 minus 1 all upon 4 whole square. Then look at the top, continue this equal to square root of 1 minus root 5 minus 1 whole square upon 16. Root 5 minus 1 whole square upon 4 square is 16. This equal to square root of 16 minus root 5 minus 1 whole square is root 5 square minus 2 root 5 dot 1 plus 1 square all upon 16. Now this equal to square root of 16 minus root 5 whole square is 5 minus 5 minus minus plus 2 root 5 minus plus minus 1 whole upon 16. Square root of 16 is 4, so 1 upon 4. Square root of 16 minus 1 minus 5 is 10 plus 2 root 5. So cos 18 degree equal to 1 by 4 times square root of 10 plus 2 root 5. So root. Now we go to next question 13b. Question number 13b. To prove sin 36 equal to 1 by 4 times square root of 10 minus 2 root 5. Now we have sin 18 degree equal to root 5 minus 1 all upon from solution of 38. Then cos 36 equal to 1 minus 2 sin square 18 degree, because cos 2 theta equal to 1 minus 2 sin square theta by using this formula. So cos 36 equal to 1 minus 2 sin square 18, that is root 5 minus 1 whole upon 4 whole square. This equal to 1 minus 2 into root 5 minus 1 whole square upon 4 square is 16. This equal to 1 minus root 5 1 whole square, root 5 minus 1 upon 2 8 the 16. This equal to 8 minus a minus b whole square from, so root 5 square whole square minus 2 dot root 5 dot 1 plus 1 square whole upon 8. Now this equal to 8 minus root 5 square 5 minus 5 minus 1 plus 2 root 5 minus plus minus 1 whole upon 8 equal to 8 minus 6 2 2 plus 2 root 5 whole upon 8, taking 2 common 1 plus root 5 whole upon 8 equal to root 5 plus 1 whole upon 2 power 8. We obtain the value of cos 36. Again, we know that sin 36 equal to square root of 1 minus cos square 36 degree, because sin theta equal to square root of 1 minus cos square theta by adding this one time. So this equal to square root of 1 minus cos 36, that is root 5 plus 1 whole upon 4. So root 5 plus 1 whole upon 4 is whole square. Now this equal to square root of 1 minus root 5 plus 1 whole square. Whole upon 4 square is 16. Taking LCM, 16 minus root 5 plus 1 whole square, that is root 5 whole square plus 2 dot root 5 dot 1 plus 1 square whole upon 16. Square root of 16 is 4, so 1 upon 4 square root of 16 minus plus minus root 5 whole square is 5, minus plus minus 2 into root 5, 2 root 5 minus plus minus 1. This equal to 1 by 4 square root of 16 minus 6, so 10 minus 2 root 5. So sin 36 degree equal to 1 by 4 times square root of 10 minus 2 root 5. So root. Now we go to next question. Question number 14. 14A. So here cos theta equal to 1 by 2 times a plus 1 by a. To prove cos 2 theta equal to 1 by 2 times a square plus 1 by a square. Now this equal to cos 2 theta. Cos theta is given, so using formula cos theta in terms of cos theta. So we can write cos 2 theta equal to 2 cos square theta minus 1. 2. The value of cos square theta is 1 by 2 times a plus 1 by a is whole square minus 1. 2 into 1 by 2 whole square is 1 by 4. Then a plus 1 by a whole square minus 1. 2 into 1 by 2, that is 1 by 2. A plus 1 by a whole square is a square plus 2 dot a dot 1 by a plus 1 by a whole square is 1 by a square minus 1. This equal to 1 by 2. A cancel, so a square plus 2 plus 1 by a square minus 1 into multiplying by 2 by 2. Then we can take 1 by 2 common from this and this term. 1 by 2 common, remaining a square plus 2 plus 1 by a square, 1 by 2 common, remaining minus 2. Plus 2 minus 2 cancel out, remaining 1 by 2 a square plus 1 by b square, that is RHS. Now we go to next question. 14b. On 14b, we have given that cos a equal to a plus 1 by a. Cos a equal to a plus 1 by a, that is cos a equal to 1 by 2 times a plus 1 by a. To prove, cos 3 equal to 1 by 2 times a cube plus 1 by a cube. Now LHS equal to cos 3. Cos 3 equal to 4 cos cube a minus 3 cos a. Now 4 cos cube a, putting value of cos a here, 1 by 2 times a plus 1 by a is whole cube, since cos cube a, minus 3 cos a into cos a, 1 by 2 times a plus 1 by a. This is equal to 4 into 1 by 2 whole cube, that is 1 by 8. Then a plus 1 by a whole cube minus 3 into 1 by 2 a plus 1 by a. 4 by 8, that is 1 by 2. 4 to the 8, so 1 by 2 a plus 1 by a whole cube minus here 2, 3 into 1 by 2, 3 into 1 by 2 a plus 1 by a. Taking 1 by 2 common, 1 by 2 common, remaining a plus 1 by a whole cube minus 3 times a plus 1 by a. This 1 by b is common. Now this is equal to 1 by 2 a plus b whole cube, a cube plus b cube plus 3ab, so 3 dot a dot 1 by a, 3ab a plus b, 1 a plus 1 by a minus 3 times a plus 1 by a. We use the formula of a cube plus b cube. A plus b whole cube equal to a cube plus b cube plus 3ab a plus b. We use this formula. Now this equal to a cancel out, this plus 3, a plus 1 by a minus 3 plus this cancel out, this equal to remaining 1 by 2 times a cube plus 1 by a cube, that is RHS. This term and this term cancel out. Now we go to next question. 14c. On 14c, solution here. b tan theta equal to a. B tan theta equal to a. That is tan theta equal to a by b. To prove a sin 2 theta, a sin 2 theta minus b cos 2 theta equal to b. Now LHS equal to a sin 2 theta minus b cos 2 theta. Now a sin 2 theta in terms of tan, because tan theta is given, 2 tan theta upon 1 plus tan square theta minus b cos 2 theta in terms of tan, 1 minus tan square theta all upon 1 plus tan square theta. Now this equal to a times 2 tan theta, a into tan theta, 2a tan theta upon 1 plus tan square theta minus b into 1 minus tan square, that is b minus b tan square theta all upon 1 plus tan square theta. Now taking LCM, 1 plus tan square theta, LCM 2a tan theta minus b, minus minus plus b tan square theta. Now putting the value of tan theta is a by b, so 2a dot a by b minus b plus b into tan square theta, a by b whole square, so a square upon b square all upon 1 plus tan square theta, a by b whole square, that is a square upon b square. Now this equal to 2 a square upon b, 2 a square upon b minus b plus square will be cancelled, a square upon b, a square upon b all upon b square plus a square all upon b square, taking LCM. 1 divided 2 a square upon b plus a square upon b, 3 a square upon b minus b all upon a square plus b square all upon b square equal to 3 square b square minus b square all upon b Okay, in this question, here must be plus a sin 2 theta plus b cos 2 theta plus b minus b plus b minus b plus b minus then 2a square upon b minus a square upon b, that is a square upon b plus b. Now this equal to a square plus b square all upon b upon a square plus b square all upon b square. This equal to a square plus b square all upon b into b square upon a square plus b square. A square plus b square cancels out, remaining b square upon b, that is b equal to RHS. So in the question, the middle sign must be plus. Okay students, this was for today. Have a nice time. See you soon.